In this video, we're going to apply sine law to solve the word problem. The Pont du Gard near Nimes, France, is a Roman aqueduct. An observer in a hot air balloon, some distance away from the aqueduct, determines that the angle of depression to each end of aqueduct is 54 degrees and 71 degrees respectively. The closest end of the aqueduct is 270 meters away from the balloon. Calculate the length of aqueduct to the nearest tenth of meters. So, as you can see on the right, I have created a sketch which represents this the context of this word problem. There are two angles of depression between the horizontal and the angle of depression is the angle between the horizontal and imaginary line, how we are looking down from something from above. Okay, so the angle in blue is angle A, equals 71 degrees, and the angle in red, angle A, is 54 degrees. The distance AB between the balloon and the nearest end of aqueduct is 270 meters. So where to calculate the length of the aqueduct? I gave already, since this is the main question, I gave this length x variable as we're going to use it for the main question of the problem. Right. So we're working with the triangle ABC. Because it has got the length which we are looking for. Right, as you remember, the first step in solving questions which have sine law application, we are to label the triangle properly. So the side which is overlooking side A, the side which is overlooking angle A is lowercase a. So x equals A. Right? So the side which is overlooking angle B is lowercase b, and the side which is overlooking angle C is lowercase c, which is given. Right? So based on this, we pick up the quotients of sine law which we need. So the quotients of sine law which we need, first of all, should contain the unknown. So the unknown is A, right? It means that the first quotient is going to be A over sine of the corresponding angle of the opposite angle A. All right. Now, the second quotient is, it depends on what we are looking for, on what's given. So what's given is the side 270, right? So that's side C. That means that the second quotient we're going to make is C side over sine of angle C. Now, you remember the next step is to insert the known values. So let's see what we have. First of all, angle A. Angle A in this triangle is going to be the difference of blue angle A, which is 71 degrees, and red angle A, which is 54 degrees. So the angle which we need, I'll give it 3 letters, as I told you before, when there is a confusion with letters to label angles, we can use 3 letters. So angle B, A, C is 71 degrees minus 54, which is 17 degrees. And this is angle A for our sine law in the previous line. What else? So C side is given. We need to find angle C. What I want you to notice on the sketch is that angle A, the red one in red, this one, and angle C are corresponding angles. Why? Because they are created by the line which is intersecting two parallel lines. What does this mean? It means that angle C is 54 degrees, right? So now we have everything to input into the equation, into the sine law. So A, which is unknown, which we are looking for, it will stay unknown. Instead of sine of angle A, we are going to write sine 17 degrees. Now the other side, the right side of the equation, C side is 270 degrees over sine of the opposite angle, which we found, which is 54 degrees. Now all we have to do is to cross multiply and to isolate for the unknown. So if we, at the next step, we cross multiply, we'll get sine 54 times A equals sine 17 degrees times 270. You remember we don't input sine into the calculator until the very last step to get the accurate answer. So finally we isolate A by dividing both sides of the equation by sine 54. So we get sine 17 degrees times 270 over sine 54. And if you input all of this in the calculator, you'll get 97.6. So the answer is that the length of the aqueduct is 97.6 meters.